Alright, so we start now. So we are going to start computer vision now. Of course, it's not a course on computer vision, so won't cover too much, but we'll still cover pretty decent. So computer vision. Now you are given an image, okay, and you are supposed to recognize some car in this. Okay, how will you do that? So you want to make a system that recognizes cars or whatever. So if there is a car in this, I say yes, else I say no. So which classification problem is this? This is still binary classification. And how can I solve this? How can I solve this? So let's say if image is 100 cross 100 pixels, is 100 cross 100 a big picture? Is 100 cross 100 pixels a big picture? It's a very small one, right? Very small. So it's almost tiny. Now we'll keep it simple. I won't make it 3 right now. If I do this 3, what does it become? So it's RGB, colored image. I won't keep it colored right now. I'll keep it simple black and white. Okay. Tell me, how do I design a neural network to recognize, to do this binary classification? You already know it. You've done MNIST before. So how can I make a neural network? So I'll make a vector, right? I have how many columns here? I have 100 columns and 100 rows. I can stack one column over the other, and the fact that I am stacking columns over each other, does it mean it will be wrong if I stack rows over each other? Nothing wrong with that, right? You can do whatever, but once you make a choice, you need to fix. Okay, so it's okay even if you say my my x1 is this pixel, my x2 is this pixel, my x3 is this pixel, and so on. But once you fix this mapping, it should be the same for whole training data set, right? So otherwise neural networks, they don't care what is your x1, what is your x2. So it is for us, we will say I'll keep this and then second column and then third column, stack it over each other. My input layer will become, so my input layer becomes x1 to x 10,000. What comes next? Hidden layer. So maybe what do I want here? 10,000 to maybe 1,000. So let's say I have 1,000 here. Next what should I do? I output directly, or maybe one more hidden layer. Okay. So let's say somewhere around 100, and then let's say 1. How many parameters are there in this neural network? Roughly. So 1000 into 10k, that gives me 10 million already, right? So 10 million now plus 1 lakh, right? So already I am getting, so number of parameters are 10 million plus. What is good or bad with this? So, will this classify things? Yes. What is good or bad with this? So let's say even if I get rid of this, I still have this many parameters. Get rid of 1000 and I keep 100. So even in that case you will have, so you will still have 1 million parameters. So you have decreased it 1 orders of magnitude, but do you expect it to do that well now? Directly from 10,000 you are compressing it to 100.
But sir, you can have another inner layer of 100, so like it won't be 10 million, but it will be around 1 million, 2 million.
That is fine. So if you have x1 directly, but the point here is you are compressing a 10,000 dimensional information in 100. Later if you have 100, that's okay, because you have already compressed this one into this. Not saying this is wrong, right? But may not be the desirable thing to do in all the cases. Compressing 2 orders of magnitude from here to here is just too much. You usually don't do that. Okay? So assuming we are going with this, we have 10 million plus parameters. So everything that you have said is right. What's right, what's good or bad with this?
It will need more computation.
You have just too many parameters. And tell me, what is the question at hand? Binary classification. I do all this compute. What is the probability that I'll be wrong if I toss a fair coin, and if it is head I say car, if it is tails I say not car. So I'll be 50% accurate without doing anything, right? And with all this compute I don't know how much accuracy will I get unless I get something close to 99% or more, right? So you are coming basically from 50% to, so there is a lot of compute involved here. In today's world 10 million parameters are nothing, right? You can run it on your laptops as well. Think of those days when these things were being designed. 10 million was just huge. Okay. So for example, LeNet 5, the first super working neural network that was designed by Jan LeCun for this MNIST data set, it had roughly 55k parameters, and that was huge because we are talking about 90s, 1995, 97, 98. Okay. So if you want to do binary classification, random guessing gives you already accuracy of 50%. Okay. And we are assuming that our data set is not skewed. That means roughly 50% are cars therein and roughly 50% are not cars. So we don't really need to do anything. We can still use good old feed forward neural networks and do our task. Now what happens if I have many more classes instead of just one class? Instead of just these 2 classes, I have, let's say, C equal to 1000 classes. Then what will happen? Instead of 1, I will have 1000 in the output here. Okay. Can I still solve the problem using the same method? Yes, you can. Okay. There is nothing that stops you from doing it. So there is a data set called ImageNet data set. How many of you know about it? How many of you know about it? How many of you heard name of this? That's it. So what is this data set?
Class of 10 not commonly
class of
10, it is classified into 10 regular common images like cars, dogs, horses.
Okay, so ImageNet dataset has roughly 1.2 million images and it has 1000 classes. Okay, so maybe what you are talking about is Cipher 10, right? So 1.2 million images, 1000 classes. How will you, and every image we are taking is 224 cross 224 cross 3, and as I said before, for the time being I will drop this 3 because we will bring this 3 once we understand two-dimensional pictures. So how will you design a neural network for this? How many neurons in my input layer? 224 cross 224, whatever that number is, maybe it's more than 50,000 because 200 cross 200 will give me 40,000 already. So whatever this number is, then you cannot directly bring it down to 1000 classes in the output layer. Nobody stops you from doing it. So quickly, I mean I didn't want to, but let me quickly do this. So I have input layer 224 cross 224, then what can be my next hidden layer? From 50,000 I can,
5,000.
so let's say 5k, and then finally let's say 1000. How many parameters will this particular neural network have? Assume this is 50k. 50k into 5k, that gives me, so 50 into 5, that gives me 250 million, and whatever the next one is not comparable with this. So 250 million already, 250 million means 25 crore. Okay, so you are already having huge number of parameters, and right. So feed forward neural networks, they become computationally very heavy once you have huge input size, and in case of images you will always have huge input size, you won't have small inputs with small features. So
HD images में तो क्या होगा?
exactly, so in HD you can have maybe 2000 cross 2000, so 2000 cross 2000 cross 3, that already gives you So now we need to start talking about how can we improve this. So if anybody asks you question, do you really need so if anybody asks you this question, do you really need CNNs? Answer is no, we don't really need them. But then do we really need them? Yes, because otherwise the number of parameters will be huge. So let's say we talk about this now. Same problem. So this is not a car. I mean, this is not a car either, but let's say this is a car. Now, so let's start understanding about something called convolutions. How many of you already know what is a convolution? So I'll now somehow magically say that this particular car, okay, this particular image is maybe 6 cross 6. So this is 1, 2, I have 6 columns. I should have drawn this car with a different color maybe. So this is what we have. Okay. How do, this is my 6 cross 6 image. Let's see how do you convolve. So this is the sign for denoting that we are taking convolution. Now let's say you convolve it with you are having an input image of size 6 cross 6. We are not in colored right now, even though this car is in red color. You take convolution and what do you finally get? So now assume we have, give me some numbers here. 5, 6, 8, 9, 3, 2, 1, 4, 10, 11, whatever. So, I mean, I should have taken example from here. So, just a second. So, what I'll do is, so I don't think it makes sense to do all this on board. I'll directly go to slides of and doing. Now, how do you take convolutions in this case? See, you have, this is called a filter and this is the input image. What you do is you superimpose this over this, multiply them element wise, whatever comes becomes my answer here. So what will I get at this first corner? So 3 into 1, 1 into 1, 2 into 1, and then I have to add them. So this gives me 8, this gives me 0, and this gives me 11. So this gives me minus 3. What comes next? No, this is not matrix multiplication. Can you multiply these two matrices? 6 cross 6 and 3 cross 3? No, no, no. So, so what will come here? एक बार इधर. What will be here? Once more. See, this is 3 cross 3. take this as it is, superimpose it over here. Multiply the element here with the element here and add all these things. So this thing goes there, all these guys will be multiplied with 1, so their sum will be 8. All these guys will be multiplied with 0, so their sum will be 0. All these guys with minus 1, so their sum will be minus 11. So 8 minus 11 gives you minus 3. Tell me what happens in the next iteration. I mean next, what will come next? No, this is not matrix multiplication. You took this, superimposed there, multiplied element wise and added everything. Okay? And this is convolution for CNNs. Convolutions for electrical engineers is different. Now, so how will my next element come?
minus 3 की जगह minus 5.
Okay, minus 5. Minus 5. Okay. So, what will be the next element? So, next time you will multiply it with this. You will shift one right. This shifting one right is called stride. Okay, so stride is 1 in this case. You just move by 1. So what will be my next element? So 12, this is 12 minus 16, that gives you minus 4. What happens next? Eleven minus 11, that gives you 0. And what about the last one? Sixteen minus 8, that gives you 8. कोई बात नहीं, 8, fine. So you have 8 there. Next. So first row is complete. What element should come here? This one. So this row is done. You come this side. So this time I am going to talk about this part. 3 minus 13, that gives you minus 10. What will be the size of my output? 4 cross 4? 4 cross 4. This operation that you are doing, so this operation of taking this 6 cross 6 as input, doing this operation with 3 cross 3 and getting this is called convolution. So CNNs में जो convolution है, this is what it is. Right? So is this operation fine? Okay. Stride is 1. But who said you will skip just 1? You could have skipped 2, 3, 4 and so on. We'll come to these things. Okay. Now instead of 6 cross 6 and 3 cross 3, if I give you n cross n and f cross f, what will be my output size? n minus f plus 1. So your output size will be n minus f plus 1, n minus f plus 1. Now tell me, is it necessary for me to have both these dimensions n cross n? Can I have n1 cross n2? Why not? So he says you won't be able to take convolution with this if it's a rectangular matrix. Is that true? If this were 6 cross 7, or if this were 8 cross 6, what will happen? Right. So you can still do it. There is nothing that stops you from making it n1, n2. Right? We are keeping it simple for our calculations. Else, this can be n1 cross n2 and so on. Sorry? Yes. Right? So this is what it is. Is this operation fine? All right. So now what you can also do is, so let me just copy this. क्या बोल रहे हो? कॉपी नहीं किया. अरे यार, ये स्ट्राइड भी आएगा अब. Now tell me one more thing. So this was convolution. Now if you take something called padding, so now what do you do in case of padding is, what do you do in case of padding for in any general thing? So add an extra layer. This was 6 cross 6, now it becomes 8 cross 8. Okay. So you just extend this and all zeros there. Okay. You still take convolution with this. What will be the output size? Six cross 6, and you can still do that in same manner. So if your padding is P, what is the formula? What will be the output size if padding is P? So in this case P is equal to 1. N plus 2P minus 1, N plus 2P minus 1.
So what is the purpose of padding?
Right? Now, same question, but let's say this time we also do change in stride. Okay? No, I really need slides for this. हाँ. What is the purpose of padding? भाई कोई बताएगा मेरे को? अरे यार my mistake. So of course yes, N plus 2P minus F plus 1, right? So thank you. Alright, so these slides are from CS 230 and so this is what we have talked about, right? We have talked about this thing that if you have big images, then feed forward neural networks really explode in the number of parameters. So we were talking about this one. Okay. So this is the same number, same matrix, and probably the same matrix here as well. Okay. So this is fine, we have done it. I'll talk about this in a minute. Or maybe we can just talk about, right? So let me start from the beginning then. This is image classification, right? We know this is binary classification problem and it already has a lot of parameters. Object detection is the problem of detecting objects in the image. It is different from classification. In classification you were just supposed to say, so if cat was not here, if it was here, it wouldn't make any difference. But in this case, in case of object detection, you don't have to just tell me there is car, you have to also tell me where is it. So you have to put the bounding box. So if this car was not here, but if it were here, then your output will change. then you can do neural style transfer and so on. So this is your image, this is the style image, you can give it different styles. We have talked about this part. Now we have talked about this one. So somebody asked me, how do we decide on filters, right? This is also called as kernel. Now let me talk about this first. Let us say this is your input image of size 6 cross 6. 3 cross 3 output will be 4 cross 4. 0 is, so you are just dealing with black and white images. Which values will my pixel take if it is a 6 cross 6 image? All these values, give me the range of all these values. Yes. 0, 1. So what is the range of numbers that can come here? ऐसा मत करो यार, रिकॉर्ड हो रहा है, मतलब ये काटना पड़ेगा मेरे को. 6M के बच्चे मेरे को ये नहीं बता रहे हो. I mean, right, 256, 0 to 255. Okay, so you can have from 0 to 255. अब जब यही नहीं बता पाए तो ये क्या बताओगे कि 0 ब्लैक है कि 255 ब्लैक है? 255? 255 is white, because this gives you the intensity of a pixel. So if intensity is maximum, it is maximally white. If intensity is 0, it is black. Okay, now so you get this 256 shades of gray, okay, from white to black or from black to white. Now, so if it is 10, go and look at this image. This is brighter side. So let us say this is not 10, so this is 10 written here, but here you can assume it is 255. जो कलर में जो कॉन्ट्रास्ट दिखाया है, this should have been pure black, this should have been white. I mean, this is how it is looking like. 0 is completely black, so these are pixel 0, may not be even just this. This may be 0. So this half is this, and that half is this. So these 10, they don't really represent the intensity of these. This is just for representation purposes. This side is brighter, this side is darker. You take convolution with this particular filter, what happens? You get this. Tell me, if this were not 6 cross 6, if this were 10 cross 10, but same size, same representation, in the sense that first half is 10 and second half is 0, how will my output look like? If this were not 6 cross 6 but 10 cross 10, I take convolution with the same filter, how will my output look like? Output will be, size बता दो एक बार तो, 8 cross 8. So I will have 8 cross 8 here. What will happen to, so I will have 8 cross 8 na, so I will add 2 more things here and then 2 more things out there. What will be the elements of these extra columns that you have added? All zeros, because you will have 10 10 10 out there, 10 plus 10 plus 10, and then these guys will be multiplied with 0 and then negative of the same thing. So all these numbers will be 0 here, and similarly all these things will be 0 here. What happens if this becomes 100 cross 100? It does not change, right? Now this is a remarkable property of this filter. What is it? wherever you see a transition from brighter side to darker side, it is recognizing this edge. Okay. Now let us say if you have a 1000 cross 1000 size image and there are two places, so there are two transitions. You start with 10, so you have 10 for let us say maybe 250 columns. Then you have 0 for maybe let us say 250 columns. Then you have 10 for 250 and then you have 0 for 250, and similarly for so let us say for all the columns you take convolution with this filter, what will happen? See, how many transitions do you see? Once you are going from 10 to 0, then 0 to 10 and then 10 to 0. So there are three transitions. Tell me whether it will be able to detect those transitions and nothing else. See, for first 247 it will be identically 0, right? Then when you are coming from 0 to 10 you will have things like this again. So at this place you will still have 30 these two columns of 30. What comes next? So this is fine. Then you will have zeros for around 250 again, around 250. Okay. Then when you go from 0 to 10 you will have minus 30s here. Okay. And then when you go from 10 to 0 it will be again plus 30s. Okay. So why minus 30 here? So you see it does not capture just transition, it also captures transition from black to white or white to black. Okay. And tell me one more thing, a small filter size, a small filter of size 3 cross 3 is able to do this for 6 cross 6 image, 10 cross 10 image, 1000 cross 1000, 10,000 cross 10,000, you choose the number. So this is very powerful in that sense, and it does not depend on image size. In your image, you may write this down, in your image wherever you see a vertical edge it will be able to detect it. I flip this around, right? So let us say this time I have, so this time let us say I have a different kind of image, 10 in the first 250 rows, then 0 in the next 250 rows, then again 10 in 250. So 10 0 10 0 and each one in 250 rows. Okay. Tell me what will this filter do? So let us not make this complicated, just make tens here, all tens, all zeros. What will this filter do? Will it be able to detect this edge? No. Right? So this is strictly a vertical edge detector. Now can you give me horizontal edge detector now? I take transpose and that should do it. Nice. Okay. So now you see the purpose of these filters. Any questions here? Next, So more edge detection. We have already done this, right? When you go from brighter side to darker side, you had some numbers, other way around you had negative of them, so it is even able to detect the which kind of transition is it, right? So it is going from darker side to brighter side and vice versa. And then you already told me how to do a horizontal edge detection, so this one will do it. What about this guy? This has some edges. So how many edges are here? These are the edges, right? And you will need maybe both. Next. So now if you take convolution of this image with this filter that we talked about, your resultant is this one. There are so many vertical edges here, and this filter indeed gives you just those vertical edges, everything else is sidelined. Okay. So if you run a horizontal edge detector here, as you see it here, you don't see as many edges except maybe this one and this one, right? Just one more minute. Or maybe we'll start in a few minutes. So we'll be back in 10 minutes.